Alright, Grace, this is activity 6. I think there's quite a few kids that still haven't done this, but you're supposed to draw the free body diagram with all forces labeled and calculated. So here's the box. So you've got the force of gravity, which is mass times gravity. There, I think it's a 120 kilogram box, so this will be 120 times 9.8. And then this is going to be the force normal, that's up. And then there's the force applied, which is 65 newtons. It says it's a frictionless floor, so there's no friction. So that would be your free body diagram. Calculating the acceleration of the crate is going to be the force is equal to mass times acceleration. So they've got a force of 65 equals a mass of 120, and then you solve for the acceleration. And then how long does it take the crate to travel 10 meters? Well, once you have the acceleration, you'll also know the initial velocity of the crate is 0, and you know the distance is 10 meters. So you can tell them to use a season 2 equation, but they can use the equation delta x equals VIT plus 1/2 AT squared. They've got delta x, VI is 0, and then they can solve for t. And that's how you do problem 1. Problem 2, and always with these problems you can tell them to start with a free body diagram. We've got the chair. Mama pushes this way with 200 newtons. Papa pushes back the other direction. We don't know how hard he pushes, but we know that the chair has an acceleration in this direction of 0.5 g's. Well, if the kids ask, well, what's a g? Well, you can say, g, great question, or g, great question, I guess. A g is 9.8 meters per second squared. So 0.5 times that is 4.9, and that's what 0.5 of a g is.
You don't do times 10. That's why people get messed up, because it makes it.
So this now is our acceleration. We've got the mass of the recliner, so we simply take 40 times 4.9, and that gives us 196. I think it comes out to 196. You can double check me on this, but and so this means that according to the equation, sum of the forces equals mass times acceleration. The sum of the forces is 196. So if this is 200, this must be 196 bigger than this. So this would have to be 396 newtons, right? And so now there's a net force to the left from Papa, and the chair would move to the left. Okay, similar problem here, and you can have the kids see that the cart is moving at a constant rate. It speeds up at a constant rate, so it has an acceleration. The first thing you want to do is you want to take your information given here, here, and here, and find acceleration. Remember, acceleration is change in velocity over change in time. So just simply take the change in velocity from here to here and divide it by 2 seconds, and you'll have an acceleration. It should come out to 6 meters per second squared. And then the box, the 85 kilogram box, right here must have this acceleration. So where does it get that acceleration? Well, if we were to zoom in on this box, there's a force this way from the wall, and we'll call this force normal x. Whoops. We'll call this force normal x. There's a force normal y, and then there's the force of gravity. So this force normal x, if you take your 6 meters per second squared and plug it into F equals ma, you're going to take 85 times 6 meters per second squared, and you'll get a net force, and that net force will be equal to this force normal in the x direction. Okay, so that's how you do that problem. And then the last one, a fisherman carrying a 1.4 kilogram fish on a line gets into an elevator, and the elevator is accelerating upwards at 3 meters per second. squared. What is the force of tension in the fishing line as the elevator ascends? So if we draw the free body diagram for the fish, there's an upward force of tension on the rope, right? We're looking at the fish right here, and then there's a downward force of gravity, mg, for the fish. We know the fish's mass, and we know gravity, so we can do 1.4 times 9.8. If I take my acceleration, so anytime I see acceleration, I think, okay, I'm probably going to be finding the net force. I take that 3, I multiply by the mass of the fish, and I'll have the net force, right? So then the net force is just the difference between these two numbers. So if, let's say, this comes out to 10, this number comes out to 10, and your net force comes out to 5, then this force here must be 15, right? Because 15 minus 10 equals 5. Okay, so that's how you solve the first page. And then second page I can help you with tomorrow in class.